Hello all, we'll be looking at the second string matching algorithm, that is Knuth-Morris-Pratt algorithm. They proposed a linear time algorithm for string matching, and you can see that it is achieved with a complexity of O of n. And the worst case, at the most, you can go for O of n plus m, where n is the length of the string and m is the length of the pattern. So what it helps is, suppose that T is a string, the text that is given, and P is a pattern that needs to be matched. You can see that it helps in avoiding unnecessary comparisons with elements of T that has already been compared in the previous stages. So there'll be no unnecessary backtracking on T. Basically, you can say a KMP in short. KMP algorithm, it helps in pattern searching and in finding all the pattern efficiently when compared to the previous algorithm. So basically it has, you can say, a special function known as a prefix function, or we call it as the LPS array. This array actually tells you the length of the longest proper prefix of the pattern that is also a suffix of the subpattern. So you can see you'll take a subset or a subtext and you can see that the prefix and the suffix are somewhere same. Some set of letters will be same in the prefix as well as in the suffix. So this will help you in going back in the text and again finding the match, because we already matched them in the previous stage. There's no need to do it again. So, and the time complexity is also very less. We have already said that. It's used in a variety of applications like text editor, search functionality, and any other application where a fast and efficient string matching algorithm is required. Okay. Now, this is what I was telling. That is, this function, basically a KMP matcher algorithm, consists of the basic algorithm that helps in matching the entire sequence. But what supports it is the prefix function. So you can see this is a prefix function pi. Usually write it as pi. It's called as a pi table, where we find out which is the longest prefix that also appears as the suffix. So this prefix function, it's for encapsulating knowledge about how the pattern matches against shifts of itself. This information can be used to avoid useless shift in the pattern P. So you can see it will avoid backtracking on the string T. So we'll look at the examples, you'll understand it better. And in the KMP matcher, it will find the occurrence of P in T and returns the number of shift that has occurred to find the actual pattern. So this is how a basic idea of a prefix function. Suppose that a pattern is given of length m and P is labeled as P from starting from 1 to m. Then the prefix function for the pattern is given by the function named pi. We call it as a pi table or the prefix table, whatever it is. And the index is given from 1 to m itself, because that is where the match occurs. The pi, for every pattern from 1 to m, the prefix table will have an index from 0 to m minus 1, such that you can see the equation is shown like this. Pi of q is max of a value k, where k is less than q, and you can say p of k is a subset of p of q. So P of Q is the length of the longest prefix of P. That is also a proper suffix of P of Q. So we will understand what is the meaning of this with the help of an example. We'll take one of the examples like this and see how it works. So this is an example given in the CLRS text or prescribed textbook. I'll show you another example. Okay, suppose that we are given a pattern, say P is equal to A, B, A, B, A, C, A. Okay, the length of this is 1, 2, 3, 4, 5, 6, 7. So M is equal to 7. Okay, now looking at the index, we generally write it varies from 1 to M, we say, right? So we can say P of 1 is basically A, P of 2 is B, etc., etc. And P of 7 is A. Okay. Suppose this is how we, now suppose that you want to find the pi table. So pi of any value, the longest prefix of, we don't know what is the length of the prefix. So suppose that the length of the prefix that we're going to find is the character Q. So we say pi of Q is given by, so it is basically, what is Q? The length of the longest prefix in the string that we are currently looking at of P of 1 to Q. That is also a suffix in that particular string. Okay, when we say it's usually the length of the longest proper prefix. Why we say proper is because we exclude the entire substring itself as a prefix. We don't look at the entire string as a prefix, only the portions or a sub part of the string only we say. Okay. Say for example, finding out the pi table or the pi array, we call it pi array or pi table for a pattern of P. That is how do we find it out is basically looking at the prefix and the suffix. So suppose that you're looking at the substring, say you're looking at the first character of the string, say this one. Okay. Now, if you take the first character, say Q, put a, if Q is equal to, I'm individually, first I'll show just how individually we are trying to do, but there's no need to write a detailed explanation when it comes to ask you what is the prefix function. Suppose ചോദിച്ചു കഴിഞ്ഞാൽ ഇത്രയും detail ആയിട്ട് എഴുതേണ്ട കാര്യമില്ല. Okay, you can just simply write as a table format in this way, where you can see what is the value of Q, what is the value of P, and so on. Okay, and what is pi of Q. This way we can write. I'll show you the next example. But suppose that I'm taking the first value Q, and the substring that I have taken is the first one, that is A itself. Now, what will be pi of Q? We have to find out the length of the longest prefix. Okay. Now, you can see what is the prefix here. When it's the first character, there is usually no prefix because it is the only character there, right? ഒരു character മാത്രമുള്ള, there is no need to find a prefix or a suffix. So you can just simply put a 0 for always. Pi of the first index, pi of 1 will be always 0. There's nothing to look into. Now look at the next one. Say suppose the second character we are taking. Also, we are taking the second character when the index is 2. So the substring will be AB. Take 2 characters at a time. Now it will be AB. Now you can see that the proper prefixes of this AB are, ignore the last character. The proper prefix we'll have only A. And what is the proper suffix? The proper suffix, I will write it here. Suffix is simply B, nothing else. Is there any match between these two substrings? No, there is no match. So because there is no match, we put a 0 here. Now take when Q is equal to 3, we have 3 characters A, B, A. Now tell me what are the prefixes of the string ABA. It can be either A or it can be AB. Got it? Now what is the suffix of this string? Suffix of this string will be, ignore the first character in case of a suffix. Okay, then we have BA or A. Now can you see any match between A and A? Yes, there is a match. AB and BA, is there a match? No. So the longest prefix is of length 1. Got it? The longest prefix that is also a suffix in the string. That the meaning ഇത്രേ ഉള്ളൂ. ഈ ഒരു സ്ട്രിങ് എടുത്തു കഴിയുമ്പം ഇവിടെ ഈ ഇനീഷ്യൽ പോർഷൻസിൽ വരുന്ന ക്യാരക്ടേഴ്സ് ലാസ്റ്റ് പോർഷനിലും വരുന്നുണ്ടോ നമ്മൾ നോക്കുക. So you have the longest prefix is of length 1, which is also there in the suffix. So the length is 1. Now when Q is equal to 4, we have 4 characters A, B, A, B. Now what are the prefixes? The prefixes are A, then we have AB, then we have ABA, right? Now what is the suffix? Suffix no we have B, simply B, then suffix no നമ്മൾ ഇച്ചിരി തിരിച്ച് പറയുന്നതായിരിക്കും. Okay, ആദ്യം B എടുക്കാം. BAB, BAB, then AB, and then B. Now, can you tell me which of these are matching? ABA, BAB matching. AB, AB. Sorry, it's not AB, right? Yeah, it's AB. So AB, AB, is it matching? Yes, it is matching. Then you have A also, then there's a B here. That's not matching. So the longest one that is matching is only AB. So what is the length of this pi of Q, where you have the longest matching prefix also as the suffix? The matching one is AB, and what is the length of that? It is 2. So we put a 2 here. അപ്പൊ അതിന്റെ മീനിങ് എന്താ? നമുക്ക് ആദ്യത്തെ എയും എയും മാച്ച് ചെയ്ത് നമ്മൾ 1 ഇട്ടു, പിന്നെ എയും ബിയും മാച്ച് ചെയ്ത് ഇപ്പൊ രണ്ടാണ് ഇപ്പൊ മാച്ച് ചെയ്യുന്ന അറിയിച്ചു. We put a 2 there. Okay, so this way. Now let us look at the next character. When it is A, B, A, B, A, we have 5 characters here. ഇനി എത്രണ്ണം ഉണ്ടെന്ന് മാച്ച് ചെയ്ത് നമുക്ക് നോക്കാം. പ്രിഫിക്സ് എന്ന് പറയുന്ന ഏതൊക്കെ വരും? We have A, AB, ABA, ABAB. That's all. Now suffix we got BABA, then what? ABA, then we have BA, then simply A. Is okay. Now can you tell me which of them are matching? We have a matching A, then AB is not matching. This is matching with this. AB is not matching. Then we have ABA, that is also matching. Is there a BABA? No, that is not there. So the longest one among these two is ABA. So the length goes to 3. That means we had a ABA prefix here, and we also had a ABA suffix there. So the longest match one was that one. And this way we can keep on finding for all of them. Let us look for 6. I'll just erase this. Okay, so now for the 6th character, we have A, B, A, B, A, C. So this is what we have. So what is pi of Q? We have to find out. Tell me what is the prefix and what is the suffix. So suffix will be, we have A, AB, ABA, ABAB, sorry, ABAB, and then finally ABABC. Now, what is the suffix? Prefix, we got these many. What is the suffix? Suffix is BABAC, then ABAC, then we have got BAC, then AC, and finally C. Are there any match between the prefixes and the suffixes? There is no match. So we say that there is no character that is also available in the prefix that is available in the suffix. There is no such character. So we put a 0 here. Okay, that means we did not get a match. Then look at the last one, the 7th one, that is the entire string A, B, A, B, A, C, A. Now you can see that there is only one match. You can see before we don't have to just list it out. You can see the entire thing, the only match is this character A in the beginning and A in the last. Okay, that is the only thing that is matching, because we don't have a proper match towards a suffix that is also there in the prefix. So the only character that matches with the longest length is 1. So when I ask you to write the pi table, this will be the pi table. So Q is 1, 2, 3, 4, 5, 6, 7. And the characters are A, B, A, B, A, C, A. Then we can write the pi of Q as 0, 0, 1, 2, 3, 0, 1. So this table has to be saved. This is a table or an array, whatever you call it. This pi array has to be saved such that you can compute the algorithm for KNP. Okay, so this is how we do a pi table or a pi array. So you can see the algorithm for this is given here. That is basically you were given a pattern P, you find the length, then you create a new array pi from 1 to m. Then the initial value of pi of Q, where Q is equal to 1, you can say it is 0. And we have an index K for writing the length of the largest prefix that we found every time. It can be incremented like this, you can see here. And initially it will be 0. So we start from where pi is equal to, where Q value is equal to 2. We ignore the first character and start from the second character, because we're going to compare the first character and the second character and so on. So we start from the second character, and K is what decides the first character, and Q will be the second character. That is, you compare a left character with the right character and we keep on shifting like this. So while initially k is not 0, right? K is equal to 0, it's not greater than 0. So the first time it won't enter the while loop. So we'll be comparing whether k plus 1. So you can say initially the k value will be a 0 where nothing is there. And the you have index like this. And you compare what is P of pattern of k plus 1 means you're looking at the first character, and pattern of q where q starts from 2. Okay, so you'll be looking at the second character. If by any chance both of them are same, then what we do is, because we're looking inside the pattern itself, there's no text here. We're looking the entire thing, we're looking inside the pattern itself. So both are P. Always remember that. Now, when we're comparing the two characters, if they are same by any chance, we have found a prefix that has the longest length, right? So then we increment the value of k. So we keep on doing this. And then once you find the value of k, you should also, this is the pi of q array, right? The pi of q array, that value, say you found that these two are same, then you have to write pi of q is equal to 1. The initial one is 0, that is given over here. See this? That is 0, the first one. And you suppose you found that the first two characters were same, then we increment the value of k and we put the value of pi of q inside the array at the location of q. Now currently suppose q is equal to 2. But q2 ആകുമ്പോഴത്തേക്ക് q of 2 ലോട്ട് നമ്മൾ 1 ഇട്ട് കൊടുക്കും. Okay, and so on. ഇനി suppose അത് match ചെയ്തില്ല എന്നുണ്ടെങ്കിൽ we'll just put a 0 there. Suppose it was another character. So നമ്മൾ എന്ത് ചെയ്യും? We put a 0 there. And we come back to this and we find out the next value of q, say 3. Again, k is still 0, right? അപ്പൊ ഇപ്പൊ 0 ആണ്, നമുക്കൊന്നും ചെയ്യാനില്ല, 0 തന്നെ. അപ്പൊ മാച്ച് ചെയ്യാത്തടത്തോളം കാലം നമ്മൾ 0 ഇട്ടുകൊണ്ടിരിക്കും. എപ്പോഴേലും അത് മാച്ച് ചെയ്യുവാണെന്നുണ്ടെങ്കിൽ കെയുടെ വാല്യൂ ഇൻക്രിമെന്റ് ആയി കഴിഞ്ഞു കഴിയുമ്പോൾ പിന്നെ ഈ വൈൽ ലൂപ്പിൽ കയറും. വൈൽ ലൂപ്പിൽ കയറി കഴിയുമ്പോൾ എപ്പോഴേലും മാച്ച് ചെയ്യുന്നില്ല എന്നുണ്ടെങ്കിൽ എവിടെയാണ് കെയുടെ വാല്യൂ എന്നുള്ളത് നമ്മൾ കണ്ടുപിടിക്കുന്നത്. പൈ ഓഫ് കെ ഇസ് ഇക്വൽ ടു കെ എന്ന് പറഞ്ഞ് നമ്മൾ എടുക്കും. So I'll show you some more examples. You'll understand. This is the basic idea. You can just iterate through this code by example, put the value of k and q and you can just see through it. Okay. So we'll look at another example of finding the pi array for the given examples that we'll be showing now. Say, suppose I'm giving you a string as p1, that is a, b, c, d, a, b, e, then a, b, f. Now I'm asking you to find the pi array of this. So what will be the pi array of this? Initially nothing is matching, so we put a 0. The first and the second characters are not matching, we put a 0. The prefix and the suffix of ABC, take ABC, nothing is matching. When we take ABCD, nothing is matching. But when it comes to ABCDA, you can see that there is a single match, so we put a 1 here because it is repeating. It's basically like this. You have an index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that A occurs at the index 1. That is what happens here. Okay. Then you have the matching of, when you take this B also, you see that AB is matching here and AB is matching here. So the maximum length that matches is 2. Then you have E is not matching anywhere. There's no prefix or suffix that matches, so you put a 0. Then when again you have a, you can see that A is matching here as well as here, so you put a 1. Then again when a AB comes, it is again matching, you put a length of 2. F, this is 0, and so on. So we'll look at another example. A, B, C, D, E, A, B, F, A, B, C. There is no match here, no match, no match, no match, no match. So till here there is no match, we put all zeros. But once repetition of a character comes and we see that it's there in the prefix and also in the suffix, the length is 1. Then when B comes, we put a length of 2 because the entire thing, you can see it is available here as well as here. Okay. Then when F comes, there is no match. When A comes, again there is a match. B comes, again there is a match. When C comes, you can see it is available here as well as here. So it's there in the prefix as well as in the suffix. So the maximum match length is 3. You can see this is the index itself. See? The first occurrence where it comes, that is a match that we got here. Okay, because it should come in the prefix, not in the middle. It should start from the prefix. Another one, that is the pi value here. Now P3 will see, say A, B, C, A, D, A, B, E. Okay, so the pi values here will be A, first one is 0, it's matching, so we put a 1. Then B is not matching, C is not matching, A is again matching, D is not matching, A is matching. When a second A comes, there are two values here, A here and here also, so we put a 2. Again, it is matching. Every time it's matching, we increment the value of K from, you can see here, see, K increments from K to K plus 1. Every time it will keep on incrementing. Then when B comes, you can see you have a prefix here, AAB, that is there here also. So it becomes 1, 2, 3. E is not matching to any of the prefixes. It's a new character, so it's entirely 0. Look at another example, P4. So a question like this can be asked, like what is the prefix pi array for the following pattern, or find out the pi table given a pattern, whatever it is. So in some way they can ask you whether it is correct or not. Say another example, A, B, A, C, D. Now you can see here A is matching. A comes, you can see it's matching with the prefix and the suffix are matching. When we take these three characters, the prefix and the suffix are again matching. So we write a 2 here. Then we have A, we write a 3 here. When B comes, it becomes a 0. When A comes, the first characters are matching. When A comes, the first two characters are matching. When C comes, it's a 0. D comes, it's a 0. And so on. I hope it is clear now. Okay. So we have to basically, you can say we are finding out. This is also known as the longest prefix suffix array, or we can short call it as LPS array. It's the prefix function. The entire calculation is done with the help of a function known as prefix function. It is also known as a failure function. It is known as a LPS array, and it is used inside the KMP algorithm. Okay. So how it helps is basically you can say that when a mismatch occurs, when you're doing the KMP algorithm, whenever a mismatch occurs at some index j in the pattern, this LPS array will tell us how far we should shift the pattern without checking the already matched characters. എത്രയും നമ്മൾ പുറകോട്ട് പോകണം, ഫുൾ പുറകോട്ട് പോകണോ, കുറച്ച് ക്യാരക്ടേഴ്സ് പോയാൽ മതിയോ? ദാറ്റ് വേ വി ഹാവ് ടു ഫൈൻഡ് ഔട്ട്. അതായത് മൊത്തം ഒന്നുകൂടെ റീമാച്ച് ചെയ്യേണ്ട ഒരു അവസ്ഥ, അതായത് അൺനെസസറി മാച്ചിങ് പിന്നെയും ചെയ്യാൻ പാടില്ല. So instead of restarting from the scratch, we jump back to a particular position given in the pi array. So pi array of that index will be given, the value of pi values will be taken, and only to that position so what happens is the search will be much more efficient. It will take only maximum O of n, where n is the length of the string, you can say. Okay, so it's basically the longest proper prefix that is also a suffix for that particular set of pattern, and it helps in skipping any unnecessary comparisons or repetition, what is redundant comparisons. So ഒന്ന് മാച്ച് ചെയ്ത സാധനം പിന്നെ മാച്ച് ചെയ്യാതിരിക്കാൻ വേണ്ടി അത് കഴിവതും നോക്കും. So that is a basic idea. So I hope it is clear what is meant by the LPS array, longest prefix suffix, or you also call it as a failure function. Okay, failure function, or you can say a prefix function, multiple names for it. Okay. Now this is the basic KMP matcher algorithm, where you can see that the first step that they do is given a text and given a pattern, you find out the length of them. Then you find this, there's a function called compute prefix function, which comes back to this function, where you can say that it tries to find the pi array for the entire thing, and then it calculates the pi array and stores it in a variable pi. Initially q is equal to 0, and we start from I from 1 to n, where n is the length of the text. And every time we find that q is greater than 0 and they are both not matching, we find the value of q from the pi array. Otherwise, we set the value for q. Okay, we set the value, increment the value of q, and if you reach the end of the statement, we finally set the value of q, or find the value of q like this also. Here we are setting the value, here we are taking the value of q from pi of q in these two cases. So we'll see how this works. Suppose that we have given a text like A, B, A, B, C, A, B, C, A, B, A, B, A, B, D. Suppose this is the text, and you're given a pattern like A, B, A, B, D. And suppose I'm asking you to find the pi table of this pattern, what it will be? This will be 0, 0. There's a match, then there's a match of AB, so the longest prefix is there, and this is 0. So you can just find out the value of pi like this. Now, initially the value of I will start from here. Okay, and the value of Q is what starts from here, you can say, value of Q. Initially, say you have this starts from a 1, 2, 3, 4, 5, and Q starts from 0. Okay, so in 0, you have no value, no character here. It is just simply for the sake of doing it. We have put it like this. So suppose that, okay, so this is the pi table. Okay, so now initially you can see here the value of, we clear this. Okay, initially the value of n is whatever is the length of the given string, and you have p, the length of p as 5 characters. And suppose we start with q is equal to 0 and I is equal to 1. So you can see q is equal to 0 and I is equal to 1 to n. So here you can see Q starts from 0, because every time, why we have put it as 0 here is, you can, some of the textbooks may be different, and every time you can see whenever they are matching, they put Q plus 1, because we are one step behind, because Q is 0, right? So because our index starts from 1, Q 0 ആയതുകൊണ്ട് എല്ലാ കമ്പാരിസണിലും Q plus 1 വെച്ചാണ് TF യെ കമ്പയർ ചെയ്യുന്നത്. അപ്പൊ Q ഒരു ഇൻഡെക്സ് പുറകെയിലാണ്, so we'll be always putting a plus 1 as a in the code itself. So you can, depending, we will understand, because in some steps we need that. That is why they put Q is equal to 0. Okay. So initial ഇതിൽ നമ്മൾ നോക്കുമ്പം when I is equal to 1, where I is at 1 എന്ന് പറയുമ്പോൾ ഇവിടെയാണ്, and Q is equal to 0, is there any match between the characters P of Q plus 1 and T of I? That is what is we have to see. A match ഉണ്ടെങ്കിൽ shift ചെയ്യണോ വേണ്ട എന്നുള്ളതൊന്ന് നോക്കുക. So if there is, so initially when Q is 0, we cannot enter the while loop, because we are checking whether Q is greater than 0. Then we come here and check whether P of Q plus 1 and T of I are same. Are they same in our case? In our case, you can see this is a A and this is also an A, right? Both are A. So they are same. So because they are same, what you have to do? Q plus 1 എന്ന് പറയുമ്പം P of 1 തന്നെയാണ് ചെക്ക് ചെയ്യുന്നത്, and T of I means T of 1, that is also an E. Because they are same, we have to, you can say, എന്താ ചെയ്യുന്നത്, just shift ചെയ്താൽ മതി. Look at the code. Q is equal to Q plus 1 ചെയ്താൽ മതി. Q is equal to Q plus 1. So increment the value of Q. So Q was initially here, now Q is over here. Now again we check Q plus 1. So we are now going to check whether P of 2 is equal to T of where in the next iteration. Sorry, in the next iteration. Now, once this is over, we come back where I is equal to 2 now. And in the next iteration, Q has also incremented to 1 and I is incremented to 2. Now we check the next two characters. So next two characters is again B and B, they are same. So again we increment Q. Then in the next iteration, A and A are again same. So we increment Q and I. Then we increment. So finally, I reaches here and Q reaches here. So then we check Q plus 1, that is B here and B here. They are also same. So we again increment I and we increment Q. Now Q comes on 4 and I comes on 1, 2, 3, 4, 5. I is on 5. Then you can see we are checking whether T of 5 and Q of 5 are the same. And you can see here, this is the D and this is the C, right? So we have got a D here and we have got to C. So since they are not the same, what is the next step we have to do? So before that, you can see every time we had a match, right? So where Q was incremented, while we enter this loop, wherever we increment Q, we got that q is greater than 0, and if it is not matching, both the conditions have to be true. So we do not go inside this while loop because every time till A, B, C, what was the characters? A, B, A, B. Till A, B, A, B, the four characters were the same. So because this condition is false, we always come to this eighth step, that is if. And because they are equal, every time we are shifting Q and I. Okay, every time we just keep on shifting Q and I till we come to a place where we don't get a match. So we come to a place where we don't get a match, right? So that place is, you can see in this our example, when we got I is equal to 5 and Q is equal to 4, we got a match like this. So we got a true statement here, and Q is also greater than 0. So when a situation like this comes, what we have to do? We have to set Q as pi of Q. The earlier, that is pi of Q, whatever is the value of Q, take that value and put it inside Q. That is what we do. So what is the value of pi of Q here? You can see the value of Q is at 4, right? So this is Q. Okay. Now what is the value of Q is nothing but pi of 4. Now what is pi of 4? This is pi of Q. Pi of Q il kadakana value എന്താ 2. So we got Q is equal to 2. അതായത് നിങ്ങൾ ഇനിയും backtrack ചെയ്യേണ്ടത്, we don't have to go to the entire A തൊട്ടേ തുടങ്ങേണ്ട കാര്യമില്ല. We just have to backtrack to the index 2. Now what is the index 2? This is the index value 2, right? Now you can just backtrack there and start comparing again. അപ്പം നമുക്കിപ്പം ഐയുടെ വാല്യൂ, അതായത് ക്യൂവിന്റെ വാല്യൂ 2 കിട്ടി. So I'm going to clear this and we can see how it will come. Okay, so we're going to put Q here, and the I value is still at C itself. Okay, C is equal to I is equal to 5. There is no change. Now we're going to compare whether T of I, let me erase this. T of I and P of Q plus 1, we are going to again compare. So what is T of I? It is 5 itself. And what is P of Q plus 1 is nothing but 2 plus 1. 2 plus 1, that is P of 3, and T of 5 we are going to compare. So that means we are going to compare whether the next character, because we know that AB was already there, whether the next, we found a mismatch at C and D. So we are going to find out whether the next character after AB, because AB match already നമ്മൾ കണ്ടുപിടിച്ചതാ. അപ്പൊ അത് കഴിഞ്ഞ് ഏതെങ്കിലും പാറ്റേൺ മാച്ച് ചെയ്യുന്നുണ്ടോ നോക്കാൻ വേണ്ടി we found out whether your previous one, അതായത് ഈ പറയുന്ന third character, that is this will be A and this will be C, whether they are matching. They are not matching, right? So matching അല്ലാത്തപ്പം പിന്നെ നമ്മൾ ഏത് കേസിൽ വന്നു? We are again inside this. Q is greater than 0 and we found that C is not matching to A. A is not matching to C. It is not matching. അപ്പൊ പിന്നെ നിങ്ങൾ അടുത്ത Q എങ്ങോട്ട് ബാക്ക് ട്രാക്ക് ചെയ്യേണ്ടതെന്ന് കണ്ടുപിടിക്കണം. So what do we get? Q is equal to pi of Q again. Now what was the value of Q here? The value of Q was 2, right? Now we have to find out pi of Q. Pi of Q il endha kadakkunne? 0. So we have to find Q is equal to pi of 2. That is nothing but 0. So you have to backtrack Q. So നമുക്ക് ഇവിടെ നിന്ന് delete ചെയ്യാം. Delete ചെയ്തിട്ട് Q എന്ന് പറയുന്നത് തിരിച്ച് 0 ലോട്ട് പോകും. Got it? It goes back to 0. അതായത് നമുക്ക് ഈ എ ബി സി എന്നുള്ള പാറ്റേൺ നമുക്ക് ഒരു രീതിയിൽ മാച്ച് ആയില്ല. അപ്പൊ നമ്മൾ തിരിച്ച് നമ്മൾ ബാക്ക് ട്രാക്ക് ചെയ്ത് നമ്മുടെ പാറ്റേണിലോട്ട് തിരിച്ച് ക്യൂവിലോട്ട് ആദ്യം തൊട്ട് പിന്നെ നോക്കാൻ വേണ്ടി നമ്മൾ പോകും. So now what is the next step? Now again we find out whether P of, what is it? 0 plus 1, Q plus 1, right? So Q is now 0, whether it is equal to T of I. I is still at 5. I ഇതുവരെ ഇൻക്രിമെന്റ് ആയില്ല, ഇതിനകത്ത് തന്നെ നിൽക്കുവാണ്. So we found out that Q plus 1 എന്ന് പറയുന്നത് 0 plus 1 ആണെന്ന് പറയുമ്പോൾ നമ്മുടെ ഫസ്റ്റ് ക്യാരക്ടർ, that is A, whether A is matching to C. Again it is not matching. So can we now shift again? ഇനി നമുക്ക് പിന്നെ ഷിഫ്റ്റ് ചെയ്യാൻ പറ്റുമോ? Pi of 0 എന്ന് പറഞ്ഞാൽ ഷിഫ്റ്റ് ചെയ്യാൻ പറ്റുമോ? No, because 0 is the നമ്മുടെ ടേബിൾ 1 തൊട്ടാണ് സ്റ്റാർട്ട് ചെയ്യുന്നത്. 0 is outside the bounds of array. അപ്പൊ ഇനി ഷിഫ്റ്റ് ചെയ്യാൻ പറ്റത്തില്ല. അപ്പൊ no more shifting is possible. അങ്ങനെ no more shifting possible ആയി കഴിയുമ്പം you can see that this loop, there's nothing more to go inside. So we'll be iterating the value of I to the next character. I was 5, right? Now it will move on to 6. So I will be shifted forward. So അതിന്റെ മീനിങ് എന്താ? നമ്മുടെ ഐ നമുക്ക് ഇത്രയും പാറ്റേണിൽ ഒന്നും മാച്ച് പാക്കിൽ ഒന്ന് മാറ്റി നോക്കിയിട്ട് നമുക്ക് കിട്ടിയില്ല. സോ നൗ ഐ എന്ന് പറയുന്നത് 6ൽ വന്നു. എന്നിട്ട് നമ്മുടെ പാറ്റേണിന്റെ പകുതിക്ക് നമ്മൾ ഇടയ്ക്ക് ഒന്ന് നോക്കി 2ൽ, അവിടുന്ന് മാച്ച് ചെയ്തില്ല. അപ്പൊ പിന്നെ 0ന്ന് പിന്നെയും നോക്കി, എന്നിട്ടും മാച്ച് ചെയ്തില്ല. അപ്പൊ പിന്നെ നമുക്കിനി ഇവിടെ ഒന്നും മാച്ച് ചെയ്യാനില്ല, നമുക്ക് മുന്നോട്ടുള്ള ടെക്സ്റ്റ് നോക്കണം. സോ ഇഫ് യു ഹാവ് ടു ഗോ ഫോർവേഡ്, ദെൻ യു സ്റ്റാർട്ട് ഫ്രം എ അഗെയിൻ ആൻഡ് എ ഹിയർ അഗെയിൻ. അപ്പൊ നമ്മൾ ഐ ഈസ് ഈക്വൽ ടു 6ഉം ക്യൂ ഈസ് ഈക്വൽ ടു 0യിലും q plus 1, we are going to check whether q plus 1 is matching to t of 6 now. So there is a match. Then again a and b, there is a match. Then again there is no match between a and c. Appo nammal pinne backtrack to the location of pi of this. So we'll go back to 1. And then we come here and see whether it is matching a and c. It is not matching. So again we have to go back to 0. And this keeps on repeating. So you can try out the entire series and see how it works along with the code given. But this is the basic idea. Okay, the prefix function. And we keep on doing this. So what happens is, basically what it does is, if there is a match, you shift forward both I and q. Understood? If there is a match, you shift forward both I as well as q, because I will, the for loop also will go forward and q will also go forward. But if there is a mismatch, you'd go back, displace, or you backtrack backward, and backward, either backward shift in the q എന്ന് പറയുന്ന പാറ്റേണിനകത്തുള്ള, you shift only q but not I. How do you shift q? By replacing q with whatever is the value inside the array pi of q. അങ്ങനെയാണ് നമ്മൾ shift ചെയ്യുന്നത്. Otherwise we move forward. So in this cases we'll be only shifting backwards. പക്ഷെ ഐ മാറത്തില്ല, ബിക്കോസ് അത് ഇതിനകത്ത് തന്നെ നിൽക്കും. ദിസ് ഇസ് എ വൈൽ ലൂപ്പ്. ഓക്കെ, ആൻഡ് യു കീപ് ഓൺ ഡൂയിങ് ഇറ്റ് ടിൽ ദർ ഇസ് നോ മാച്ച്, ടിൽ ദർ ഇസ് എ മാച്ച്. ഇപ്പൊ മാച്ച് ഇല്ല എന്നുണ്ടെങ്കിൽ വൈൽ ലൂപ്പ് ഇങ്ങനെ കണ്ടിന്യൂ ചെയ്തുകൊണ്ടിരിക്കും. മാച്ച് ഉണ്ടെങ്കിൽ മുന്നോട്ട് പോകും, അഗെയിൻ ഫോർ ലൂപ്പ് കണ്ടിന്യൂ ചെയ്യും. ഓക്കെ, സോ ഇഫ് ക്യൂ ഇസ് ഈക്വൽ ടു 0, ഈ ഷിഫ്റ്റ് ചെയ്ത് എപ്പോഴേലും ക്യൂ 0 ആവല്ലോ. 0 നമ്മുടെ ഇൻഡെക്സിലുള്ളതല്ലോ, ഇറ്റ്സ് ഔട്ട് ഓഫ് ദ ലെഫ്റ്റർ മോസ്റ്റ് ബൗണ്ട് അല്ലേ. അപ്പൊ ക്യൂ 0 ആയി കഴിഞ്ഞാൽ പിന്നെ നമ്മൾ ഫോർ ലൂപ്പിൽ ഐ ഷിഫ്റ്റ് ചെയ്യും. ഓക്കെ, സോ ദാറ്റ് ഇസ് ദ ബേസിക് ഐ. So I hope this is clear. Please look into an example, and so you can see KMP. This is one of the basic idea of what both the algorithms is. KMP matcher എന്ന് പറയുന്ന ഈ algorithm. This is KMP matcher, inside which there is compute prefix function. KMP matcher algorithm matches the text against the pattern P. But whereas compute prefix function matches P, the pattern itself, against itself. Okay. And this is the complexity of both of them. You can see there is a for loop from step number 4 to 10 that will run around the length of the pattern, that is m times. So you can say the computation of this will be O of m. And when it comes to KMP matcher algorithm, this itself takes maybe m times it will work, right? Then in step number 1 to 4, that is a constant time, you can say. But then here you have a loop in the for loop here, and it will maximum run up to the length of the string, that is n. So you have O of n. So maximum you can say it is O of n plus m, or simply you can say O of n, because n is the greatest value. So whereas in the previous cases we had O of n into m in naive algorithm as well as the previous algorithm we learned. But in this one we have only O of n. So it is a much better algorithm when compared to the others. So I hope this is clear. Please look into more examples. Thank you.